Yeah, so good evening. In the last videos, somewhere we have some problem with these bit manipulations, right? So we will discuss about that bit manipulation later. Okay. Now I want to start. Okay. I want to start another a new topic. So which is nothing but a hash table. Okay. So what is mean by hash table? How we can able to work with this hash table data structure I need to demonstrate for you people. Okay. So hash table data structure. Sir, in this, what topics we are going to cover? So the first topic here is introduction to hash table. Why we need to go for hash table? How we can able to represent this hash table? All these things. So next and after that hash table, how to store the data, what are the common operations, okay, what are the operations so that we can able to perform on data, that is a hash data structure. In this mainly we have one special function is there called a hash function, how to work with this hash function, and we will see implementation of a hash table, how to store the data, how you can able to perform. Sir, I am going to explain only basic three operations like insertion, deletion, and then searching. Okay. So next and after that, in hash table, there is one terminology is there with the name collisions. So what is mean by collisions? Okay. And if any collision is there, sir, collision resolution methods are there. Okay. We are going to discuss about that. So next and after that, one of the collision resolution method is nothing but so linear probing and implementation of this linear probing. Next and after that, quadratic probing. Okay, and implementation of this quadratic probing and its implementation. Next and after that, sir, separate chaining method is there. So, and its implementation. So these topics we are going to cover in this hash table data structure. So let us talk about the introduction to hash table. Sir, very simple. Listen carefully. If you take any search algorithm, okay, if you take any data structure, how we can able to do search algorithm is we have some various techniques are there. Okay, we have various techniques are there. If you take anything, for example, consider the basic, I want to search for an element inside an array. Okay, so in the case of in the case of in the case of searching algorithms, so consider the problem of searching for a value in an array. I have an array is there. I want to search for an element in this array. So if the array is not sorted, if the array is not sorted, then the given we have to compare the given key value. Okay, we have to compare so the given key value with all elements one by one. Okay, we have to compare this key value with all elements one by one. So it will take a time complexity. Okay, it will take a time complexity as big O of n. That means we need to compare all the elements, right? Worst case, sir, if the array is sorted, then time complexity, anyway we will discuss about that. Time complexity is a big O of log n, like this we are going to get. That means in the case of linear search, the time complexity is big O of n. In the case of a binary search, that is the another right. Once if the data is sorted, this is the search what we have. So big O of log n time is going to take. Okay, log n time it is going to take. Sir, this is our normal searching, but hash table is going to improve this sorting, improve this searching technique, sir. So here big O of n is very large when compared with the big O of log n. At the same time, big O of 1 linear time. Sir, within one step I can able to perform search operation. Most efficient searching algorithm, right? Yes. So that is nothing but this hash table data structure. Of course, we have some disadvantages are there. So it is possible to get, okay, it is possible to get the location of a given key, the location of a given key, sir, by using some magic method. We are going to use some magic method. By using that, we can able to get the location where your data is available, within a small function you can able to get. Okay, so almost sometimes maybe a bit more complex will be there, but almost, okay, but almost it takes big O of 1, that is linear time, it is going to take, not linear, constant time, it is going to take a constant time. Okay, so hash method or so hash function, okay, works just like this magic method, so for this, we are going for this hash table data structure. In the hash table, insertion, deletion will take some time, but searching operation is going to perform very efficiently because internally it maintains one hash key concept, hash function concept. But how you can able to take that and how to store the data in this hash table one by one, we are going to explore with the help of beautiful examples. Can you please confirm, is this introduction to this hash table, is it clear for everyone? Please confirm. Okay, right. Now, sir, the next one, what we are going to discuss here is, what is the next one? We have hash table is there. Sir, what is mean by hash table? What is mean by hash table? So already complete introduction I have given, just we need to write some statements, beyond that nothing. Sir, hash table is a data structure. Hash table is a data structure that maps, okay, that maps keys to the values. If you have keys and corresponding values, then something like dictionary only, something like map only. The best data structure, old data structure, what we have here is hash table. Okay, next, sir, each position of the hash table, each position of the hash table is called as a slot, or some people may use the word called bucket. Each position in the hash table is called as a slot. Sir, the hash table uses hash function. The hash table is going to use a hash function to calculate, okay, to calculate an index of an array, or index of a value. Suppose if you want to perform insert operation, or if you want to perform delete operation, or if you want to perform search operation, you need some special key value, right? One index value is required. So for that, we have to implement hash function. Okay, so there are different methods are there. Okay, so the process of storing data using hash function, the process of storing the data in hash function. Okay, so the process of storing data using hash function in a hash table, as follows. What steps we have to follow? First one, we have to create an array, okay, of size n. We have to create an array of size n. Then, so this array is called as hash table. This array is called as hash table. Next, we have to find the hash code. We have to find the hash code of the given data by using hash function. By using hash function or hash method, we have to find out hash code. Okay, next, sir, take modulo of hash code with a table size, with a table size. Okay, with a table size. Correct, to get index of an array, to store the data, to store the data. Okay, anyway, I will explain this process by diagram, don't worry. Next, finally, we have to store this data in the position that calculated, that we calculated. That's all. This is nothing but what we have. Sir, now we will see how you can able to work with this. But before doing this, what are the common operations that we can able to perform? What are the common operations we can able to perform? Very simple here, insertion of data, next and after that deletion of data, next and after that searching for data. These are the three common operations that I am going to explain in this complete hash table tutorial. Now, sir, what is the first step? If I want to store any data, we have to create an array of size n. This is called as hash table. So consider my requirement is, sir, I want to create a hash table with a size 10. So this is nothing but my hash table, sir. Okay, this is nothing but my hash table. And these are called as slots. 0th location, maybe first location, sir, second location, so third location, okay, fourth location, so fifth location, so sixth location, so seventh location, eighth location, ninth location, like that I have. So 0th location, so first location, second location, so third location, fourth location, fifth location, so sixth location, seventh location, eighth location, ninth location, like this I have. Sir, now after this, what we have to do? Find the hash code of the given data by using hash function. Sir, here I'm going to take one hash function. For example, consider I want to insert the data 13. So my hash function is going to return same 13. Okay, like hash function for any number I is equal to I itself. So whatever number you are passing, what is the hash code for that function, for that number? Same number itself. Now what we have to do? Take modulo division of hash code with a table size to get the location. That means we have to divide this 13 with table size. What is a table size? 10. What output we are getting? 3. That means in the third location, we have to insert 13. Now I'm taking 15. Sir, what hash function is going to return? Same like this one. Sir, now what will happen? If you take 15 percentage 10, sir, what output we are going to get? 5. Like that we have to store. Here we are going to store 15. Sir, I have taken something like 171. So your hash function will be, generated number hash code is nothing but 171. So divide this 171 with the 10. Output is 1. So here we are going to get 171. Suppose if you take 123. Sir, hash code is the same 123. So 123 percentage 10 is nothing but 3. But here, if you see, already third slot is filled by some other number. Third slot is already occupied by some other number. Here we can't store this. So this is called as a collision. This is called as a collision. Okay. So how you can able to solve this problem? We have three methods are there. One is linear probing. Second one is a quadratic probing and a separate chaining. Like this we have. We will discuss with examples. Don't worry. But the agenda of these are nothing but we are going to change this hash function. Okay. Beyond that, nothing is there. Anyway, in the implementation, I will explain clearly how it is going to work. Okay, right, sir, I think you people got a clear clarity about the basic nature of this hash table. Can you please confirm everyone, is it clear? Up to this, is it clear for you people? Please confirm. Yeah. And can you please confirm, is 5 o'clock students are there in this? 5 o'clock students. Yeah, good, good, good. Right. Now we will see what is mean by this hash function, how it is going to create a hash function, and directly we will see implementation also. Sir, can we only store integers in the hash table? If we take string, how you can able to calculate index? That is called as a magic method. You can write in any style. For example, consider I have strings are there. Maybe I'm going to implement, I will take first character in the string. Okay. And I will check, I will convert that into ASCII code and I will divide with %10. Based on that, I will store that string. Or I will take a length of the string, okay, and I will calculate some number. For that number, I may apply some algorithm to get another number. Based on that, I will store any approach or last character. Okay, like that we can anything, any one main point we have to consider. Okay, even for objects also. So IDs will be there, right? Based on that we can do. Right. Sir, what is mean by hash function? So a hash function, or I can say hash method is a function or method, is a function or method that generates, okay, that generate index in a table, index in a table or for the given key value. For the given key value, it is going to generate key value, or I can say objects. Sir, an ideal hash function, an ideal hash function generates, the ideal hash function generates a unique, a unique key value, sir, a unique hash code it is going to generate. Generally, it is always recommended to generate. Internally, it is not required. How it is going to work? That we will see in Java. Okay, because hash code function is related to the memory management, and JVM is going to be connected with memory management and it will fetch where it is available. Okay, so that hash code is different from this one. Yeah, hash code will be present in object class. So we have to write a hash function which should generate always unique value. Okay, so unique hash value for every I can say every value. It is going to generate unique hash value for every given object or given hash value. Yeah, it is different from predefined hash function. See, that is completely different. Okay, whatever concepts I am explaining now is with respect to hash table data structure. Actually, it is a old data structure. We are not using this, but it is a part of our syllabus. That's why I am explaining. Okay, so this hashing is different from the predefined hash thing what you have seen in your hash code like that. Of course, concept is the same, but that is different from here. Now, sir, I want to implement this. I want to implement this hash function, hash table. How you can able to implement basic operations I need to perform on this hash table. Let us see how we can able to do this one. How you can able to do this one. I will implement a program for this requirement. Okay. Mm, right. Sir, now listen carefully. I am going for a hash table data structure. Class hash table like this I am taking. In this hash table, first of all, every hash table will have a size and it is an integer array. I am taking like this. Then, sir, I am taking a constructor. Within this constructor, I am going to provide a size. So with that, I am going to assign size of the hash table. Okay. Next, I want to create an array with this current size, whatever size you have given. Maybe if my hash table size is a 10, we need to create an array to hold 10 objects. Like that I'm taking. Sir, after that, what is the default value for this array? We know 0 is the default value since it is integer array. But I don't want to take 0, sir. Okay, I want to initialize all my hash table elements with -1. I want to initialize all my hash table elements with -1. That means what? So initially, I am creating one hash table. Okay, 1 second. So I'm creating a hash table. Okay. So I'm creating a hash table like this with all my initial values as -1. So one second location, third location, so fourth location, fifth location, so sixth location, so seventh location, eighth location, ninth location. I think it is sufficient. This one is not required. Let us number this one. So 0th location, so first location, second location, third location, so fourth location, fifth location, sixth location, seventh location, eighth location. IO, unfortunately we have deleted that. So this one will become ninth location. Like this I have. For our next purpose, future purpose, I am going to create another paint and I will store here. Okay. So now see here, this is my hash table. And what I have created here, whenever you are creating an object, okay, whenever you are creating an object like, so hash table HS is equal to, otherwise H is equal to, so new hash table. Whenever you are creating like this, then immediately what will happen? All these values are going to be assigned with -1. This one will become -1, this one will become -2. Oh sorry, -1, so -1, -1, so -1, -1, -1, -1, -1, -1, like this we are going to get. Okay, so like this we are going to assign. We have to pass the size as a parameter. Yeah. I think in this example I have taken 10, right? So let us pass a 10. So it is going to create a hash table with 10 elements. Sir, can you please print this hash table? I want to see. So after this, which function we have to implement, sir? Print function we have to implement, right? That's why what I'm going to do here is, sir, I will print all the elements present in this. I will print all the elements present in this. So void, I'm taking print function, and it is something like array only. That's why, sir, first I will print a message like system.out.println of, so content of hash table. Okay, content of hash table is nothing but for integer I is equal to 0, I less than, so size of the hash table I plus plus. So system.out.println of, I will print that index value and a value which is associated in that. I'm going to take like this. Sir, now let us print first of all what output we are going to get. I need to compile this program. Okay, I need to compile this program. So let's compile this code. So I am taking Prakash Java C and I am taking test.java. Is the code is going to work? Yes. Java space test I am taking. Sir, are you seeing the content of hash table is -1, -1, -1, like this I have. Sir, I want to add an object into this hash table. I want to add an object. So I will take one function called void add. Otherwise, sometimes if collision is there, for example, let us take this example. Here you can see. Suppose if I am inserting 22, where it is going to be inserted? Here it will insert. Suppose if I am giving 42, is it possible to insert this? No, because in this content already some element is there. So that's why in such a case it is going to return true. In this case it is going to return false. Like that I am going to implement which function? Add function. So this add function return type is nothing but I will take boolean. So boolean add, so it is going to take some value. Okay, sir, how you can able to store? Very simple. If your a of hash code, is equal to -1, then your a of hash code will become the value which you have given. At the same time, you can return true, saying that value is inserted. Suppose if a of hash code is equal to is equal to -1 means, then we have a room for that. If it is not equal to -1, then I am going to return false. Sir, everything is okay, but what is that hash code? We have to compute. That is our main agenda, sir. Hash code is equal to, I am taking one function called compute, which where I am going to send this value. It will return hash key for that. Okay, it will return hash key for that. Sir, in integer, I am taking compute function, which will take a value. How I am calculating, sir? So how I am calculating this hash code value? Sir, value percentage size. So what is the size of the table? 10 means that value percentage size. So that will become hash code. In this example, suppose consider I want to insert 23. Sir, we are going to send this 23 to compute function. So what is the size of hash table? 10. Sir, where it is going to be stored? In third location, correct, right? So element is vacant is available, so it is going to return true, saying that element is inserted. Suppose if you are trying to store 24, so 24 percentage 10, we are going to get 4 and it is able to store that element. Sir, now I am giving 33. Sir, 33 percentage 10, that function returned 3 value. Is it possible to store that value? No. Immediately we are going to get false. In the output, you can see that 23 is located in this location and that 24 is located in this location. But there is no room for 33. Okay, now let us see how you can able to do that. I think task completed. Just we have to write it. Now, sir, I am going to call this. How I am going to take system dot out dot, so println of hes dot add of 20. What number we have taken? I forgot. 23. So 23 I am adding. So after this hash code dot print. So I think this function is not hes, h is the object. Let us compile this. Now run this. So initially all the values are -1. Now that object got added and output we got 23. So similar to this, let us try to add 24. So what will happen? Is that object is going to be added or not? Yes, you can see 23, 24 object got added. Now, so try to add 33. Is that object is going to be added? Sir, that 33 false, because we don't have any vacant position to push this value. Like this, it is going to be stored. Okay. So I think you people got very clear clarity about so how this insert operation is going to be performed. Now let me take some elements like 23, 33. Okay. So similar to this, I want to insert a 50. Okay, similar to this, I want to insert something like 104. 104 already occupied. Let me give 105. Next I'm giving 177. Okay, next I'm giving 777. Here we are going to get false, and I'm giving 999. Let me check. Yes, almost some vacant positions are there, but still we can't add all the remaining values also. Okay. Yes. Sir, my question for you people is this a constructor implementation? Is this print method implementation? Is this compute method implementation? Is this add method implementation? Is it clear for everyone? Please confirm. Right. Sir, why we need to initialize to -1? Because by default we are going to initialize with 0. Generally by default we will take 0. But here, if you because our hash function is what? Modulo division with the table size. So if 100 is there, 100 is the data. If you divide that 100 with percentage 10, what output we are going to get? Reminder, 0, right? That's why for representing default values, we are going to use 0. And sometimes hash function is also going to return 0. Not correct, right? So that's why we are going to use a separate method to store default values. Definitely -1 won't be there. Is there any possibility that a key value will be -1? Never. That's why I'm going to take this -1. Generally, this is not good because we are going to represent all these things with the help of objects, all these things. By default, null value should be there. That we will see in our upcoming classes. Okay. Right. Sir, now I need to implement one more function. Sir, can you please perform delete operation? Yes, it is also going to return Boolean value only. So the function name is nothing but a delete. Delete keyword is there? No. So it is going to take a value. It is going to take a value. We have to delete this value. Sir, as usual, we need to calculate a compulsory hash code for this value. And just basic constraints we have to check. What is that constraint? So if that constraint is satisfied, okay, then I'm going to take a of that hash code. I'm going to reset to -1 and I will return true saying, yes, my object got deleted. Otherwise that object is not deleted. Sir, what condition we have to check? Two condition. First of all, with that hash code, there should be an empty value. Okay, there should not be an empty value. Right? If you want to perform delete operation, the first constraint is that room should contain some data. Then only we can able to delete it. Otherwise, what is the need to delete it? And so that a of hash code value, that room contains this person, then only we can able to delete. Okay, suppose consider 33 or 23 is located in which location, in which room? 23 got accommodated in third room. If I'm giving 33, definitely it is going to remove, but 33 is not there, right? You need to check that room is filled with someone and that someone is equal to the name which you have given. If these two constraints satisfied, then assign that value to -1 and return true. That's all, nothing more than this. Sir, now after this, better I will print system dot out dot. Okay, so println of h dot. So I am doing delete operation. Which item? Let us take 33. 33. What output I am expecting? False, because that element is not there. Yes, sir. So is there any change? 1, 2, 3, 4, 5, 6 locations are filled. 1, 2, 3, 4, 5, 6. So return type is false. Now, sir, the same thing. Can you please delete 23? Yes, 23 content is there. So that's why immediately it is going to return true. If you want, you can cross check. Sir, we are getting true. So previously 23 is accommodated in third room. Now it got vacated. Okay, so like this we have. This is nothing but how you can able to perform delete operation. Sir, next, of course, last operation, which is very important operation. The main agenda is nothing but this one only. What is that? Boolean. So search I am taking. Boolean search I am taking integer value. Okay, Boolean search I am taking integer value. Of course, process is the same. As usual, we have to take a hash code. So by using this compute function, I'm going to take hash code. So if what is a constraint? A of hash code, A of hash code is equal to value, then we have to return true. So otherwise we have to return false. That's all. Sir, now let us call these methods. So now I want to call search operation by passing 33 and I want to call search operation by passing 999. 33, is it available? No. 23, is it available? No. Okay, so let us cross check those two outputs. So false, true. This value is not there, this value is there. Like that we can perform. If the value is not matched, then like if value not match, where delete operation, it will return false. Okay. Suppose if you are giving 100, what output we will get? That element is not matched. Similarly here also, if you are trying to delete, if you are trying to search for 100, if the element is not available, it will return false. Very simple approach. Let us cross check how it is going to work. Yes, false, true, false. So this is nothing but the basic implementation of hash function, how it will be. I think, sir, you people got very clear clarity about implementation of this hash table. Can you please confirm everyone? Is the concept is clear for you people, guys? I request everyone to please respond. Clear? Right. So the next one. So what is the next topic that we have? Collisions. Basically with the hash table, we are controlling the placement of values. Yes. So next we will see collisions. What is mean by collision? So when a hash function, okay, when a hash function generates, when a hash function generate the same index or hash code for the two or more different keys. For same key, it will generate same value. But if the keys are different, but still it is generating same hash code, that is nothing but index value, then the problem. So then this problem is called as collision. This problem is called as collision. So a hash function should return unique address for each key. For every key it should return unique key. But practically, is it possible? Practically, so it is not possible. Practically it is not possible. Like this we have. Let me talk properties of a good hash function. If you want to take a good hash function, so what are the properties that we need to maintain? Very simple, same property. So it should provide so a uniform distribution. It should provide a uniform distribution of hash values. This is the first property. And we have to choose a hash function, so which can be computed quickly. It should not take more time, because if it is taking more time, then searching operation will become very complex. Okay. Quickly, and returns unique id, like this we have. Then we have to choose a hash function. Okay, we have to choose a hash function. Okay, so with a good collision resolution technique, compulsory we have to follow this collision resolution technique algorithms. Otherwise, definitely there is a chance of getting collision. And we have to choose, okay, and we have to choose a hash function. So which uses the necessary info provided in the key. Okay, compulsory that information should be encrypted. Means what? Sometimes hall ticket numbers, from that hall ticket numbers we have to generate so hash key values. Like that we have to take. Okay, Next and after that, it should have a high load factor. It should have a high load factor for given set of keys. Load factor means what? For example, if you take a string buffer, do you remember in string buffer somewhere I discussed the maximum capacity is 16. If capacity increased, I mean, if the values are increased, automatically it is going to shift to 34. We are not required to store manual. I mean, we are not required to update the capacity. Automatically, it will change it. So same rule is there even in hash table also. I mean, I'm talking about predefined hash table. So 10 is the actual capacity of this hash table. So once if the data is increased, then immediately it will shift to 20 automatically. Double size it is going to maintain. Like that, we have to prepare load factor. So anyway, we are not going internally about this, but we will solve how these collisions we are going to occur in our hash table. So you have seen already that collision, right? So for example, in this example program, when you are trying to insert a 23, it is inserted. Okay, 23, it is inserted. When you are inserting 33, it is returning false, saying the room is not available. But how many objects are there? 1, 2, 3, 4, 5, 6, 7, 8. But still, two locations are there, right? So that is the reason what we have here. So to overcome that only, we are going for collision resolution techniques. Something like the problem in queue got overcome in circular queue, right? In the same style, sir. Okay. I think you people got clear clarity about this. Can you please confirm any doubts up to this, everyone? Is the concept is clear? Right. So now we will see collision. Okay, we will see collision resolution methods. So what are the different methods are there for solving these collisions? Okay. So collision resolution methods. So now here, so hash collisions. Okay, sir. Oh, I have written collections. So hash collisions are practically so unavoidable. You can't able to avoid, sir. Definitely we are going to get a problem. Suppose consider I want to insert a 23. I got some problem. Next, so I mean I have inserted 23, it is inserted 33. Sir, we have a problem. So we have shifted to the next location. Then there I want to insert a 44. That a problem will come, right? Again we have to move to 55. So 55 again problem. Definitely there will be a problem. Okay, but how beautifully we are solving, that is the very important aspect. Okay, and unavoidable when, so when we are hashing large number of values, this is nothing but what we have. So the following are the techniques so that are used to find the alternative location, location in the hash table or hash table for the given objects. For the given objects, sir, what are the techniques that we have? We have linear probing is there. Second one is nothing but we have quadratic probing is there. Okay, so third one we have separate chaining is there. Like this we have three techniques are there. All these three techniques one by one I'm going to explain. Let us see linear probing and its implementation. Sir, 1 second, please wait. Right, sir. I will explain theoretical approach for this. Later we can go for practical implementation. Now consider I want to perform insert operation. So insert 3, next and after that 13, 23. So 33, 43, 53, 63. This is the values that I want to insert into the hash table. Now we will see how it is going to be calculated. Sir, what is the first step? Sir, we have to take, okay, so we have to take first normal method I am applying. What are the objects? Now, listen. So I want to perform insert operation. So I want to perform insert operation. Objects are, so 3, so 13, 23, so 33, 43, so 53, 63. Like this I have. Now, sir, I am trying to insert the first 3 by using normal approach. This, for the given element 3, what hash code we are going to get? So already we implemented, right? What is that hash code? Sir, we are going to get value percentage size. Okay. What is the value? 3. Percentage, what is the size? 10. So it is going to return 3. In third location, that object is going to be stored. Okay. Now I want to take next element 13. Sir, what will happen? So 13 percentage 10. So it is going to return 3. In third location, we have to store 13, but this one is already occupied. So I can't able to insert. Immediately we are going to get a false. This is the problem what we are facing in our normal hash table concept. Sir, here what I am going to do is I will implement this hash function beautifully. So what is the first one that we have? We have implemented a compute function where it is going to take, so value percentage. So value percentage size we have taken, right? This is the approach which we have followed in linear problem. Now what I'm going to do is, sir, I'm going to take another method which is going to return, okay, which is going to return next value, which is going to return next value. That means what, sir, maybe next item it is going to return. That is how it is going to work. I am explaining with the help of example. Don't worry, I will implement this. Okay, now listen carefully. First I am taking 3. Sir, 3, for this what value we are getting? 3 percentage 10, which is nothing but 3. In this location, the object 3 got stored. Now I am giving 13. Sir, it is also going to return same value. It is also going to return same value. But that room is already occupied. So what I am going to do is, I will go one step to the next. So fourth location, is it vacant? Yes. Try to push here. Next, take the next object. Sir, it is also going to return 3 only. Okay. So check next value. Next is also filled. So go to the next one. Okay. Like that, sir, 33. Like that, 43. Like that, 53. Like that, 63. Even if you have 73, it will be filled from here. Even if you have 83, it will be filled from here. Even if you have 93, it will be filled from here. Now, if you are trying to insert a 103, so the room is not available. Don't tell that the hash table is having some rooms. No, the rooms, complete rooms got filled. So there is no chance to place the values, right? So this methodology, what we are using is nothing but linear probing. That means continuously we are searching for the elements and we are storing. Okay. I think you people got clarity about this linear probing. So can you please confirm, is the theoretical approach, is it clear for you people? Is the theoretical approach, is it clear for you people? Right. Okay, right. Sir, anyway, how to go for implementation of this? And again, in this also we have some problems are there. How to overcome that problems? All these things I will explain in the tomorrow's session with the program. Sir, after inserting 1323, then if you need to insert a 24, then so there is no vacant. There is no vacant. So we have to go for next location. If it is vacant, it will be filled. If it is not vacant, again it will go for the next one. Definitely room will be there. Consider 10 rooms are there. In that only 5 people are there. But I don't know which room is vacant. So I will take you and I will search in the first room. So if someone is there, I will put it in your second room. If second room is also filled, I will put it in third room. Like that I am going to do. This is linear fashion. Okay. So in the linear also we have some issues. So that how you can resolve, I will explain in the quadratic probing. In the quadratic also we have some issues that we can solve in separate chaining. Separate chaining is the best approach. By using linked list, we are going to implement that. Anyway, I will show you all those things, sir, in the tomorrow's session. Okay. Right. I will upload these running notes within few minutes. You can able to download. Thank you. Yeah, and one more information. So tomorrow maximum we are trying to finish this hash table. Tomorrow we will finish this hash table. So from day after tomorrow, I'm going to start a tree data structure. Okay, day after tomorrow onwards, I'm going to take a tree data structure. Okay. Yeah. Right. Right, sir. Thank you.